In the following video, let's take a look at solving differential equations by separation. So let's look at the differential equation dy dx is equal to x over y. So separation is possible when you can put all of the x variables on one side and all of the y variables on one side. This is a very simple example. We're going to multiply both sides by y and both sides by dx. And we get y dy is equal to x dx. What we can do here is now integrate both sides. We get the integral of y dy. That's going to be y squared over 2 plus c. And then the integral of x dx is going to be equal to x squared over 2 plus d. If we move this constant of integration to the other side, we have two arbitrary constants adding / subtracting together. What we get is another arbitrary constant, so we'll call it y squared over 2 is equal to x squared over 2 plus e. How about that? Let's not use e because that can oftentimes be something else. Maybe let's call it c1. So now we have y squared over 2 is equal to x squared over 2 plus c1. So multiplying by 2 on both sides, we get y squared is equal to x squared plus c1 times 2. Multiplying an arbitrary constant by a scalar multiple keeps it as an arbitrary constant. We could rename it all we want. We'll call it c2 now. And then let's go ahead and square root both sides to get y. Y is going to be equal to the square root of x squared plus c2. And then this is where we'd have some initial conditions and we'd have the solution to this differential equation. Kind of cool.